Okay, so for example number one, let's read 1.41. At any instant, the horizontal position of the weather balloon is defined by x is equal to 8t feet, where t is in seconds. If the equation of the plus is y is equals to x squared over 10, the question is determine the magnitude and direction of the velocity and the acceleration when time is equal to 2 seconds. Okay, so how do we go about this problem? Ang ginapakita is ang magnitude and direction ng velocity and acceleration. But ang given is 1, ang displacement function along x is equals to 80. And the other one is not displacement function along y, but in the path, which is in terms of y and x. So using these two equations, we can still find the y function, the displacement y in terms of t, in terms of time. And then once we have x and y as a function of time, then we can derive again to get the velocity and acceleration functions. And then we need to plug in around 2 seconds to get the x component and y component velocity and acceleration. Tatatang video. Okay, so let's try to solve this one up. Dali ko last time nag-stop pero continue ko na lang kay last time wala ko na record ang 1.41 and 1.42. So we need to i-add ka na lang diretso. Okay, so that is 1.41. So first we have the given x is equals to 8t, and then ano to isa? Y is equals to x squared over 10. Lalo lang video. I don't understand. X squared over 10. And y is x squared over 10. So the required is the velocity direction. Iyon mo ko na to indicate that ginapakita is vector velocity and acceleration, meaning it needs to have direction and magnitude. So the solution would be utilize the givens. Let's start with x na lang para because first we have x is a function of time, which is 8p. If we derive this one, then it becomes just 8. The acceleration is 8. Then one further derivation will result to 0. There's no acceleration, there's constant velocity 8, and the displacement is 8p. Now, we need to find isang y, but wala sang given. Ang given lang isang plus, y is equals to x squared over 10. You can utilize this one by substituting x is equals to 80 to y is equals to x squared over 10 to get the y function as a function of time. So y is equals to x squared over 10. Let's plug in. X squared is 8 divided by 10. So this would be 64 divided by 10 is 6.4 t squared. So this is now the displacement y as a function of time. Same procedure. 12.8. Then 12.8. So we have complete set of displacement, velocity, and acceleration for x and y. All we have to do na lang is to plug in the time required, which is 2 seconds. Okay, so for x time is equals to 2 seconds, it is still 8. Ito hindi pa sa function of time. For velocity, still 0. Or let's make it simple notation na lang. Oops. Tama na. Kalma ko lang. Okay, so for y, diri may area 12.8 times 2 seconds, which is 25.6. 25.6, right? Then for y, acceleration says 12.8. So first we need to find the magnitude. The magnitude of velocity is x dot squared plus y dot squared squared root of is equals to h squared acute plus 25.6 squared. And for acceleration, yeah, that is x double dot squared plus y double dot squared, which is equals to 0 squared plus 12.8 squared is equals to 12.8. Anong unit yan? Feet per second. Feet per second squared. 3, yeah. We need to have calculator lang. Okay, so that would be 8 squared plus 9.6 squared of that is 26.82. 26.82 feet per second. Okay, so kulang na lang is ang direction. So for acceleration, yeah, obvious ka tama, wala naman sa x component. So direction na lang to this upward because it is positive. So this would be the final answer for acceleration. 0.8 feet per second squared going upward. For velocity, we need some trigonometry. Ilang y? 25.6 divided by 8. So the angle is 22.65. So for velocity, that would be 26.82 feet per second, and then 72.65 degrees. So muna subong yung velocity and acceleration 2 seconds later. Let's check sa. So makita mo din ang balloon ng parabolic ang yung path, given man sa path ng y is equals to x squared divided by 10. But at that point, it's 2 seconds. Mali mo na siya. Parabola siya. At this point, ang yung velocity is 70 something and direction. Diba? Naka 70 plus to. 72. Tapos ang acceleration niya is just upward lang. A. Ano na yan? Why does it make sense, man? Because wala ta sang x acceleration. Nyari sang y acceleration. Ang components ng velocity along x is constant, which is 8. It will always be 8. So from here, let's copy this one there. There. ang initial, mga distance. The same na sa diri nga point, mga Japan, diri nga point, mga Japan. So diri, the same, wala nang change. Diri sa pinaka-bottom, the same nga. Ang y component ang nag-change. Therefore, ang resultant na nag-change. The resultant is x and y. So kung mabra ito yung tangency line. So, yun sa atin ng y. Okay, so hope we get some problem. So let's go to the next problem, 1.42. Hari namin may isang problem. Okay. If the velocity of the particle is defined by v is equals to 2t plus 1 I plus 3j feet per second, and its position vector at time equals to 1 second is r equals to 4i 3j feet. The question is, what is the path of the particle in terms of its x and y coordinates? Okay, so let's examine the given. First time that nakita sa reading a problem in terms of vector, in terms of ijk. But do not be intimidated because it is just a matter of expression. In combine ang given sa x, kaging given sa y. Ang x mo sa 2t plus 1, and ang y mo sa 3. Nagamit ito I to indicate yung initial expression. Graph for this is x direction, initial graph for the y direction. It looks something more complicated a bit compared to other algebraic equations. But actually, ang mga siya kung di-combine siya. Ang sa position r equals to 4 plus 3j. Meaning 4x to the right, 4 units to the right of y-axis, and then 3 units upward from x-axis. Okay, so let's solve. That is 1.42. Given velocity is equals to 2t plus 1 I plus 3j feet per second, and the position is 4i 3j. At ilan ka seconds? 1 second. At 1 second, ang mga position niya. Okay? Tandem na sila. Wait ako dulu kung position niya. At time is equals to 0. But if wala yan isang given about siya position, about siya velocity at time 0, the only assumption that always works, but not all the time yet, is that the velocity at time equals to 0 is 0. Meaning it starts from rest. Ang mga isang keyword, it starts from rest. And the position is at the origin. Okay? So it starts from rest. Mga siya i-translate sa velocity equals to 0. But kung wala na si given, wala na indicate with word by word, it starts from rest. It is safe to assume that it starts from rest yet. And the same with position one, even if wala sa indicate, it is always, but not all the time, safer to assume that the position starts from rest. But if meron isang given, pwede mo ma-utilize, let's say r is equals to 4i 3j at time equals to 1 second, then may velocity that is, of course, my direction as a velocity. Kung i-move backward na sa time at time equals to 0 second, we cannot say na ang position mag-start sa origin. May given, tabi mo position, pwede ito sa work backward. Dito siya pag inahan, assume na at time equals to 0, position niya origin din. Kaya may given tabi. Kung wala na given mo, kung wala ka na isang may i-utilize, wala ka choice kundi mabalikid sa inang assumption. But galing niya, hindi lang dala. Okay? So, anong required? Ang required is actually the path, the equation with particle terms of x and y. The path in terms of x and y. So, tayo the solution. We know that velocity is dr dt into dr. In one-dimensional, in xy, it's dx dt, dy dt, or dz dt, or any mention, ds dt, whatever. But for 2D or 3D, we use our position vector r. R is of course composed of x and y and z, but in this case, x and y lang. So this is velocity, and according to given, it is equals to 2t plus 1 I and 3j. Correct? In-equate na lang ang expression into other expression which is dr/dt para maka-integrate na. Now transfer ng dt sa dr is equals to 2t plus 1 I dt plus 3j dt. Okay? What's next? We need to integrate. There are two ways to integrate, diba? Ang isa is matag ka upper limit and lower limit. Matag ka upper limit and lower limit. If that's the case, hindi ka na maghatag constant na c. Pero kung i-integrate mo ulit siya without giving explicit na upper or lower limit, then that's the time matag ka c. Kaya ang upper or lower limit na na-combine sa c. Meron disadvantage or disadvantage ang dual parameters. So, sinunod ko ang c lang ganun. So this should be r, okay, direct integration. And this would be t squared plus t, correct? Derivative of t squared, and t is 2t plus 1. Kung kurso ay hindi madula, ang madula ay yung dt. Kaya mag-integrate ka, mag-derive ka, ma-add ka differential dt. This should be 3tj. And don't forget c. Alright? That's the time na nakatag na sa boundary condition. Ang given sa boundary condition so wow is that at time t equals to seconds, the position is 4i 3j. Let's plug that in. So this would be 4i 3j. Muna ko ng position niya at time 1 seconds. So 1 plus 1 i 1 j plus c. So 4i 3j, 1 squared plus 1 is 2. 2i. 3 times 1 is 3j is c. Therefore, the constant of integration c is equals to 2i. Right? So we have to we can complete na the position equation, which is r is equals to since c is 2i, i-add ko na natin sa t squared plus t plus 2i plus 3t j. Okay? So na. Well completed na the position vector. So what's next? Again, after every step or every milestone sa iyong mga solution, you need to go back to objective. Ano objective? Ano sa required? Path in terms of x and y. You have to check kung nagalapit nga nagalapit sa iyong objective or basta nagalayo ka. So path in terms of x and y. Can we use this position vector in terms of x and y? How can we use this one? Anong ara sa position vector kung magamit siya in x and y? Remember that position r is in terms of x and y, meron tayong I and j. Meaning, t squared plus t plus 2. This is x. Correct? This is x. This is also y. That is a literal equivalent of these expressions. Nothing else na ang ginagawa. Meaning, we can equate these expressions to x and y. Because literally, that is x position along x and position along y. Therefore, we can equate x is equals to t squared plus t into, and of course, y is 3t. Now, lapit na lang din. Yung napakita is fast in terms of x and y, and luckily, our x and y displacements are both functions of time. So we can equate the two. Time, according to y here, is 5 over 3. So this would be y over 3 squared plus y over 3 plus 2. And let's simplify. This would be x, y squared 9, y 3 plus 2. Or we duplicate times 9, and x, sorry, x is equals to y squared plus 3y plus 18. So this is the path in terms of x and y, right? That is the path of the motion. Okay, so I show 10 questions. Please ask or chat sa chat box. So let's go with the third sample problems.